Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. We need to prepare both stereoisomers, or a racemic mixture, of 1-methylcyclohexanol, specifically the compound where O and CH3 are both at C1 of cyclohexane, meaning 1-methylcyclohexane 1-ol in both its stereochemical forms. The two structures shown have O on wedge and O on dash, with CH3 group representing the two enantiomers or diastereomers of 1-methylcyclohexanol. Moving on to the next step. Reaction of cyclohexene with MCPBA gives cyclohexene oxide 1,2-epoxycyclohexane via electrophilic epoxidation. The epoxide is then opened by CH3NGBr, a Grignard reagent. The Grignard attacks the epoxide in an SN2 fashion at one of the carbons. Since cyclohexene oxide is symmetric, attack by CH3NGBr at either carbon gives trans 2-methylcyclohexanol. However, reconsidering, if the epoxide formed is 1,2-epoxycyclohexane and CH3NGBr attacks, it opens at C1 or C2 giving trans 2-methylcyclohexane 1-ol. But the target shows 1-methylcyclohexanol structures. Actually, re-examining, the two structures shown both have O and CH3 on the same carbon, C1, making them 1-methylcyclohexane 1-ol, a tertiary alcohol. Wait, looking again at the structures. O is at top of ring and CH3 is at bottom of ring on the same carbon, indicating 1-methylcyclohexane 1-ol. For option, the MCPBA on cyclohexene gives 1,2-epoxycyclohexane, CH3NGBr opens the epoxide, Grignard reagents open epoxides at the less hindered carbon via SN2, giving after protonation trans 2-methylcyclohexane 1-ol. The two wedge dash structures shown could represent the two enantiomers of trans 2-methylcyclohexane 1-ol, racemic mixture, since the epoxide is achiral symmetric and the Grignard attack gives a racemic trans product. This matches option D perfectly. The two structures are the 1R 2S and 1S 2R enantiomers, racemic trans 2-methylcyclohexane 1-ol. And for the final step, option A cyclohexanone plus CH3Li gives 1-methylcyclohexanol, tertiary alcohol, but only one compound, not two stereoisomers shown as separate structures, and the product is the same tertiary alcohol regardless. Option B 1-methylcyclohexane plus Hg, OAC, to NaBH4, oxymercuration, gives Markovnikov addition, producing 1-methylcyclohexanol, tertiary, not two distinguishable stereoisomers as shown. Option C cyclohexene plus BH3 then NaOH H2O2 gives cyclohexanol, CH3Br would not introduce methyl at the alcohol carbon to give the desired product cleanly. Option D MCPBA epoxidizes cyclohexene to give 1,2-epoxycyclohexane, CH3NGBr opens this symmetrical epoxide via anti-SN2, attack to give racemic trans 2-methylcyclohexane 1-ol, the two enantiomers depicted in the question. Therefore, the correct answer is D. Therefore, the correct answer is option D.